Okay. So in this extra review, we're going to talk about cross sections and similar solids and solids of resolution. Again, we're going to do 1 through 3 together, and you're going to do 4, 5, and 6 on your own. 4, 5, and 6 at the bottom of your page. So take a look at number 1. So the square pyramid is cut along the shaded region shown to the right. Which of the following is the cross section of the solid? So pretty much what they're asking, what's the 2D figure formed by this plane cutting this pyramid in half? And what I like to do, I just look at the outside image. This guy right here. And then look and see which one of those closely matches that figure. And it's going to be B. Okay? If the cross section is going horizontally, just look at the shape of the bottom part that's parallel to that cross section. That's what it's going to be. If it's going vertically, look at that outside shape, and that's what it's going to be. When you have a cross section, you look at that outside shape. Well, in this case, that outside shape is a trapezoid. Kind of looks like a rectangle, but those edges are slanted. For 2, it says name the following solid that is formed if a triangle is revolved around a line M. Well, what I like to do, I'm trying to find a new figure form. I mirror the image on the other side. And then I connect the points that are not touching. So like these 2 points right here, this gray line and that part of the blue line are touching. But this guy right here, this purple point, and this purple point are not touching. Those vertices are not touching. So I connect them with a circle. Like so. And like so. And it's hard to tell because of all these colors. It might be easier to tell on your paper. Trying to kind of think about what 3D figures formed. Well, it looks like a triangle with a circle on the bottom. And a triangle with a circle on the bottom is a cone. And whenever you have a triangle and you are revolving it around the line, it's always going to be a cone, no matter what. So if you ever see an image like this, you don't even have to draw it. You just have to know, hey, that's going to be a cone. Just think about what 3D figure looks like a triangle. That's a cone. For number 3, it says 2 figures are similar. Their surface areas are given below, along with the volume of one figure. Find the volume of the smaller figure. Okay, well, first things first, they gave us the surface areas. Make it a fraction. Small over big. What I like to do. And then reduce the fraction. So however you need to in your calculator, go ahead, type it in. You might need alpha y equals enter. Use the ABC button, whatever calculator you have, simply reduce that fraction. And when you do so, it reduces down to 4 over 25. That's the ratio of the surface areas. Now, I'm going to write over here. We want to find the scale factor, the surface area, and the volume ratios. And scale factors always be like doing first power, surface area second power, and volume is always third power. Well, we just found the ratio of the surface areas is 4 over 25. We were given the 2 surface areas, we made them into a fraction, and we reduced them. So that's the ratio of the surface areas. In order to find the ratio of the other things, we always go from whatever we have to the scale factor. Always find the scale factor second. Is we have to take the ratio of the surface areas we just found. Remember, surface area is second power, so squared. Scale factor is to the first power, so not squared. So we're going from being squared to not squared. So in order to get the scale factor, all we have to do is do the opposite. We are going to square root. And when we square root 4 over 25, square root of 4 is 2, square root of 25 is 5. That's your ratio of your scale factor. And that seems really slow. Go ahead and fix it. Now all we need is the ratio of the volume. Well, to go from first power to the third power, we just have to cube the scale factor. So we just cube the top and cube the bottom. So when we cube the top, that's 2 times 2 times 2, which is 8. When we cube the bottom, then 5 times 5 times 5, which is 125. So that is our ratio of our volume. That's what we needed to find the volume of the smaller figure. So now that we have the ratio of our volumes, we can use that to set up a proportion. So we take that ratio you just found, 8 over 125, and set it equal to the smaller numbers in the top, so our smaller volume is going to go on the top. But we don't know what our smaller volume is, so we're going to say X. Our bigger number is in the bottom, so our big volume will go in the bottom. And it's just setting up a proportion. And then all you have to do is cross multiply. Multiply 8 and 675, and multiply 125 and X. Well, 125 times X is just 125X. Then your calculator gives you 8 times 675, which is 5,400. Then to get X by itself, all you have to do is divide by 125. So our smaller volume is, go around a little bit, it's 43.2. The inches cube, make sure you match. There you go. Now you're going to do 4, 5, and 6, which is just like these 3 problems on your own. If you need to, rewatch the video. When you're done with 4, 5, and 6, again, make sure